Settle to 4 next. So you got your circuit diagram there. Battery resistor, lamp. Yeah, the circuit below shows a small torch lamp with 2.7 and 0.42 connected in series with 2 batteries, which each have equal but unknown internal resistance. The lamp operates at normal brightness. What is the rated power of the lamp? Okay, well the first one is the power. So what's the formula for power? IV. So that is 2.7 times 0.42, 1.134 watts. Yeah?
Yeah.
With 2.7 volts across it, what is the resistance of the lamp when operated normally? So they want the resistance of the lamp. Okay, now you have a formula here, P equals IV, but you also know that V equals IR as well. So if you put that one into that one, it gives you the other formula, P equals, sorry, what am I replacing the V? Yeah, I squared R. So what does the R equal? P over I squared. So here, yep. Yes, go ahead, Jeff. 1.134 divided by 0.42 squared. I got 6.43 ohms. Yep. Okay. Right, last part is what is the internal resistance of each of the cells given that the lamp has 2.7 volts across it. So if you look at the diagram, can I scroll down?
Yeah.
You've got battery, resistor, and then if you look at the lamp is basically a resistor as well. Now, do we know the resistance here? We don't. Or, and then what's this one? I think I just worked it out. What was it? 6.43. Okay. Do we know any voltages? We do. We know that this is 1.5 and then this one here is 1.5. And we're also told that here is 2.7. Okay. Right. Now if you think about it, if there's 2.7 being used by the lamp down below, what remains up the top? It'd be 0.3, wouldn't it? Because remember, for one loop, what's the total voltage? 0. It's all used up, isn't it? So the batteries give me how much? How much do I get from the 2 batteries? 3. How much does the lamp use? 2.7. So therefore, what is left for the other 2? 0.3. Yeah? Now, if that's confusing you, no problem, okay? We could just use Kirchhoff as well. So if you were to use Kirchhoff, you would say 1.5 minus what? IR, plus or minus 1.5? Plus 1.5 minus IR. And then here, minus 2.7. We could use that one, couldn't we? But I don't really want to. Well, I suppose we do have the I, so we could use it. It says in the question, doesn't it say 0.42 amps? So I do have the I. So which would you prefer, Kirchhoff or Ohm? Kirchhoff, that's right. So I'm trying to encourage you to use Kirchhoff's rule more. So here, 1.5 minus I-OR plus 1.5 minus I-OR minus 2.7 equals 0. Okay, so we get 2I-OR equals, minus 2I-OR equals minus 0.3. So OR equals 0.3 over 2I, which is given as 0.42. Right, let's try that. 0.3 divided by 2 times 0.42. I got a small answer of 0.357 ohms.
So how did we solve 18?
There's parts of it which we haven't really covered, so.
How to find this one with the
Whoa, one at a time, So Danish.
with the formula E equals to IR.
That formula there is really only suitable for one battery, one internal resistor, and an external load.
So in this case, there's like two
It gets messy, don't use it. That V equals E minus IR business really is ideally for one battery, one internal resistor, one external resistor. So if it's not that, don't use it. I mean, you could try to. I would advise not though. Anything else? Daniel?
How
Yeah.
did you get 0.42?
It's given in the question.
Oh, that's
Yeah.
the
Current, the I. Yes. Okay, so that one's taken care of.